All right. Okay, guys. So if you're gone from class, this is like a video to help you catch up. This was a handout from class. It's in the Google Drive. It's in the email I just sent you. We started with this warm-up. Is it true that sine parentheses x plus y is equal to sine x plus sine y? What about cosine parentheses x plus y equal to cosine x plus cosine y? So is this true or is this not true? Well, we can test this by plugging in some angles for x and y. What are some angles that we could plug in?
6 and 7.
We could plug in 6 and 7. What about something that's on the unit circle?
Seems 30 and 60.
30 and 60, I like that, 30 and 60. So does sine 30 plus 60 equal sine 30 plus sine 60? That's the question. Well, what's 30 plus 60? 30 plus 60 is 90. And what's sine of 90? 1. Okay. Is that equal to this? Okay, so sine 30 is what? Sine 30 is 1/2. Okay. Sine 60 is root 3 over 2. So is 1 equal to 1/2 plus root 3 over 2? No, that's not equal to each other. So this is not true. So you could apply that same logic to cosine too, right? If you plugged in 30 and 60, you would also get an expression that's not true. So it's not true to say that sine of quantity x plus y equals sine x plus sine y, but is there a way that we can relate them? Yes, there is. So now get your notes out, and I will give you the formulas you need to know. So this is lesson 5.3. 5.3. Okay. So here's like the big idea. Are we here, guys? 5.3? A unit circle can give us things like 60 or 210, but what about 15 and 195? So right now, like on the unit circle, the only angles that you can get the values of are like increments of 30 degrees or 45 degrees, right? Or pi over 6 and pi over 4. But you couldn't get like pi over 12, and you couldn't get like 65 degrees. The question is there a way to do that right now? The only way you can do that is to use your calculator, right? You go to your calculator, you do sine, 65, you can find it. But this is a method that we can get those values even without a calculator, okay? And it's called the sum and difference identities. So this sine u plus v is just like what we kind of talked about in the warm-up. These both represent what? They are both angles. Thank you, Caden. Angle, right, u and v. And so we know that it's not true that this just equals sine u plus sine v or sine u minus sine v. However, it is true that it is equal to sine u cosine v plus minus cosine u sine v. Okay. So there is a proof of this. It's in your textbook, and I have a worksheet for the proof if you guys are want to explore that in the class. But for right now, you just need to know this identity. Sine u plus minus v is the same as sine u times cosine v plus minus cosine u times sine v. For cosine u plus minus v, it's cosine u times cosine v minus plus sine u times sine v. Do you see how this is going to help us? Maybe. Well, we'll do an example so it becomes really clear. So, moving down, like I was saying, in the unit circle, we know these angles, 30, 45, 60. We know these angles, pi over 6, pi over 4, pi over 3, pi over 2. However, if we want to find 15, 75, or 105, those are not on the unit circle. But if we can combine these angles to make one of these angles, then we can find it even without a calculator. So let's choose one of these. How about 75? how could I combine these angles up here to get 75?
30 plus 45.
40 plus 35, right? Or 30 plus 45. So we could write this as sine, for example, 30 plus 45. You can use, guys, any angle on the unit circle, any of these angles. You could use 150, you could use 300, you could use 30, any of these angles that you want. But sine 30 plus 45 would work for 75. For radians, it'll often give it to you in twelfths. So we want to convert our pi over 6, pi over 4, pi over 3, pi over 2 into twelfths. So that would be the same as 2 pi over 12 or 3 pi over 4, sorry, 3 pi over 12 rather, 4 pi over 12 or 6 pi over 12. You follow me? We just got these to be denominator 12 by multiplying top and bottom. Okay? So if I wanted to combine these to, let's say, make pi over 12, how could I combine these to make pi over 12? Let's say I want to find cosine pi over 12. How could I combine these values to make that? Which one? Mm-hmm. Yeah, so cosine 3 pi over 12 minus 2 pi over 12. I could write it like that. And really, that's the same thing as cosine pi over 4 minus pi over 6. So you are rewriting these new angles with the original unit circle angles by adding or subtracting. Does that concept make sense? We'll do an example so that you guys can see. We have that done? Okay, I'm going to scroll down a little bit. So let's say you want to find sine pi over 12. Well, we kind of set this up over on the right before, like just here. If I want to find sine pi over 12, I'm going to split that up into the difference of what two values. So really, we're going to split up pi over 12 to be, we got to kind of use something in our unit circle. So what do we do over here? We did, to get pi over 12, we did 3 pi over 12 minus 2 pi over 12. So that's what you're doing here. Sine, but remember 3 pi over 12 is really pi over 4. And 2 pi over 12 is really pi over 6. So this is what we have. Does that make sense, guys? Am I going too fast? It makes sense. So now that we have our sign written as a difference, we have our u and we have our v. What's our u going to be here? Our u is pi over 4. Our v is pi over 6. So we're just going to plug in this u and this v into this equation here. Do you see that? So it's going to be sine, if you look at above, as I'm writing it, sine, what comes first? Well, we did subtraction, so sine, let me write it, yeah, it'd be pi over 4. So it's sine u cosine v minus cosine u sine v. So sine u, that'd be sine pi over 4 cosine pi over 6 minus cosine pi over 4 sine pi over 6. What is sine pi over 4? Root 2 over 2. What's cosine pi over 6? 1/2. Minus cosine pi over 4? Root 2 over 2. Sine pi over 6? We made a mistake here. Cosine pi over 6, guys, is not 1/2. It's root 3 over 2. Sine pi over 6 is 1/2. So we end up with, when we multiply and simplify together, root 2 times root 3 is root 6 over 4. Root 2 times 1 is just root 2. And it's also over 4. So we have root 6 minus root 2 over 4. And that's your final answer. Does that make sense? Yeah? Okay. So we'll pause that. Okay, guys, help me out here. 7 pi over 12, how do you make that with these values up here?
Pi over 3 and pi over 4.
And there's multiple ways to do it, but yes, 3 pi over 12 and 4 pi over 12 would make 7 pi over 12. So that's like saying pi over 4 and pi over 3. So this is equal to cosine pi over 4 plus pi over 3. Did we get that far, guys? Cool. Good job. So we're going to use the cosine the cosine sum identity. So it's, do you guys see how it's kind of weirdly, like this minus plus is not an accident? Like that's how it's supposed to be. Meaning that if it's a plus over here, it needs to be a minus here. So right here, because it's a plus, it's going to be cosine pi over 4, cosine pi over 3, minus sine pi over 4, sine pi over 3. And now we evaluate it. Yeah, sorry. So it's cosine pi over 4, cosine pi over 3, minus sine pi over 4, sine pi over 3, because that's a plus. So cosine is actually the opposite in the inside. Okay, so let's evaluate that. So cosine pi over 4 is, guys, and again, we need to, maybe you don't know it right now, but we need to get to the point where it's just like immediate. Cosine pi over 4 is, anybody? Cosine pi over 4 is root 2 over 2. Root 2 over 2. Okay, cosine pi over 3 is 1/2 minus sine pi over 4 is root 2 over 2, sine pi over 3, root 3 over 2. We multiply, we get root 2 over 4 minus root 6 over 4. That's just root 2 minus root 6 over 4. Okay? How was that? Good? Next up, so these are like kind of working in reverse. You look at the expression and you notice that it's cosine plus sine. So this is which kind of identity? Is this a cosine or a sine identity?
Cosine.
It's cosine. And is it going to be addition or subtraction? It's going to be subtraction. So we're going to have 64 and we're going to have 12. So this is really cosine of 52. That's all you have to do for this one. You're just working backwards. You look at it, you identify if it's cosine or sine, whether it's addition or subtraction, and then you plug in the u, right? U was 64 and the v was 12.
Whether it's addition or subtraction?
So because this is a plus here, it must be a minus here. If you go back up to the rule, plus in cosine means minus in the expression.
Yeah.
Plus in sine stays the same as plus here. So this one, is this a sine sum? Boys. Is this sine sum or cosine? This is sine, good. And is it going to be plus or minus? Minus, and what's my u, what's my v? So u would be pi over 2, and v would be pi over 5. So here we go, pi over 2 minus pi over 5. Okay, so this is really sine 5 pi over 10 minus 2 pi over 10, which is the same as sine 3 pi over 10. Okay, does that make sense? This is pretty straightforward, right? It's just identifying u and v. Identifying what are cosine and sine values, and then adding and subtracting and multiplying. Okay, last page, and then we are done for the notes. All right, so these are 2 example proofs. So we have more proofs that use these identities. So we've got today, we've got next class, which we learn new identities, and we have proofs that go along with them. The fortunate thing about these proofs is that it's really obvious when to use, and sometimes it's usually really obvious when to use a sum or difference identity, and that's when you look at it and you see a sum or difference inside the cosine or sine function. So do you see here how we have x minus pi over 2? Like it's like obvious. You see that, okay. So we're going to use which kind of identity? Cosine. So it's going to be, let's just go ahead and say our u is going to be x, our v is going to be pi over 2. So it's going to be cosine x times cosine pi over 2 plus what? plus, we already did cosine,
Oh, yes, it's sine.
plus sine x times sine pi over 2. Okay. What is, so cosine x is just cosine x. What's cosine pi over 2? It's just 0. Cosine pi over 2 is 0. Plus sine x is just sine x. What's sine pi over 2? Just 1. So all we have is sine x. And so that's what we want. So we're done. So this is just like almost an application of that sum or difference identity. You just identify your u and v. You expand out into the sum or difference identity, evaluate, and then it simplifies to sine x in this case. Good? Does that make sense? Next one's a little bit harder. That's why there's more space for it. Can I move down? Okay. So see how we have this is the hint here. So see we have a 3u right here. This is a hint. So whenever you're seeing something like sine 2u or maybe like a sine 5u even, that's a hint that you're going to use a sum identity. Okay, so the way that we do this is we are going to rewrite that as sine and then a sum. So rather than 3u, we could write that as what in here as a sum? We could write it as, well, you could do 5 minus 2, but we want it to get simpler. You don't want to use bigger numbers. What's the smallest way we can make it? 2 plus 1. So 2u plus u. And then what we're going to do is expand that out. So if we expand that out to sine identity, we're going to get what? Sine what? Sine 2u, good, times sine 2u times, not sine, but cosine u, plus or minus? Plus cosine 2u times sine u. So this is better, right? Notice how on the right side, we don't have any kind of like 3 or 2 u's on the inside. It's all singular u's. Do you see that right here? It's just a u by itself, a u by itself, a u by itself. So that means on the left side, I need to get all the u's by themselves. Do you see that? So we have to go a little bit further because we still have a 2u here and we still have a 2u here. We got to expand those out. So we're going to rewrite those as sine u plus u times cosine u plus cosine u plus u times sine u, and then we're gonna expand those out again. Does that make sense? So sine u plus u will be sine u times cosine u plus sine u times cosine u, all of that times cosine u plus, and then we have the cosine version, cosine u minus sine u, all of that times sine u. You zoom out a little bit. Okay, do you see that? Did that make sense? I know this is like a bit of a harder problem, but are you kind of following? We're expanding out using the sum or difference identity. Then at this point, we're going to do what here? We're going to distribute this out. So sine u cosine u times cosine u would be sine u cosine squared u. Sine u cosine u times cosine u is sine u cosine squared u. Then over here, cosine times sine, that's cosine squared sine. Cosine squared u sine u. And then minus sine u, that's sine cubed u. So if you look at this, notice that these three are all the same term. That means we can just write it as 3 sine u cosine squared u. And this will stay by itself, minus sine cubed u, and we are done. This is what we wanted. So you went back up to the top. That's what we wanted at the beginning. Okay? That makes it very clear, kinda. All right, well, we're gonna get some more practice. I'm gonna turn it back to you guys. I'm gonna pause it there.